morning, all of you. Today, my name is Yaman Rawat, and today I'm here to take a small class on the topic gravitation. So, gravitation plays a very important role in a human life. How our Earth revolves around the sun, how day and night, because of this revolution only, the day and night came into existence. So, we can say that the gravitation plays a very much important role in the human life. However, all the planets revolving around the sun, it is also due to the gravitation. How the earth atmosphere is holding around the earth, it is also due to the gravitation. So we can say that the gravitation is very important for human life. So what is gravitation? Gravitation is the universal force of attraction between all the matters. It is by far the weakest force in nature, but its range is very much as compared to the other force. We can say the gravitation force is the weakest force in the nature, but its range is very much high as compared to the other forces. Like its range varies from galaxy to galaxy and light years to light years. There is a scientist named Isaac Newton who discovered the gravitation formula. He is the greatest scientist ever lived on Earth. In 1665 in England, when he was 23 years old, he was sitting beside an apple tree. Then he saw an apple fall down from the tree. He wondered that why the apple is only falling down, why is not going up or in any other direction. He wondered that there is no one who is pulling this apple in downwards direction. Then how this apple is falling down? So he wondered, and he think that there must be a force. There must be a force which is pulling this apple in downward direction. So in many years, so by the many years of research, he came with his law, which is known as the Newton law of gravitation, in which he says that there is a force of attraction which is acting on this apple, due to which this apple is coming in downward direction. So he came with the law which is known as universal law of gravitation. According to this law, if we have any two masses m1 and m2 and the distance between them is r, then the force of attraction between these two objects will be F. The force of attraction is called gravitation force. This force of attraction is called gravitation force. Force in both the objects are same. If this force and both the forces will be same in magnitude, but in opposite direction. So we can say that these two forces are action-reaction force. Force act along the line joining of the object. This force act along the line joining of these two objects. So we can say that this is a line which is joining these two objects. So this force acts upon this line. So Newton law states that universal law of gravitation states this. Newton law of gravitation is usually stated that as that every particle attracts every other particle in the universe. He said that every particle attracts every other particle in the universe. Like take the example of this pen. This pen has also a gravity, but the mass of this pen is very much less, due to which the magnitude of the gravitation force of this pen is very much low as compared to the earth gravitation force. And that's why we are not affected due to the gravitation force of this pen. But there will be a force of attraction due to this pen. So Newton law of, so Newton law states that there is every particle in every particle attract every other particle in this universe with a force of attraction which is known as gravitation force of attraction. This gravitation force of attraction is directly proportional directly proportional to the product of their masses. As I stated that the mass of this pen is very low, so the value of force will be very low, so we will neglect the gravitation force of this pen, but it's inversely proportional to the square of the distance between their center. He stated that this force, like take the example of this m1 and taking this example of this m2, this both the object attract each other with a force of attraction called F. This force of attraction is called as gravitational force, and this gravitation force depend upon the mass of their the mass of the object. Like this force is directly proportional to the product of the mass m1 and m2, and inversely proportional to the distance between these two masses, and this distance is from center to center distance. So here we come to the formula. This formula states as F is equal to G into m1 into m2 upon r square, where m1 is the mass of this object and m2 is the mass of this object, and r is the distance between center to center distance between these two objects, and G is the universal gravitation constant.